next step into space has begun. Development has started on a gigantic booster that will give the United States an advanced space capability. The Saturn space rocket will be capable of reaching the planets. It can orbit very heavy satellites, 15 tons or more. When assembly of the first rocket is completed, man will be dwarfed by the immense rocket. It will tower almost 200 feet from its base, as high as a 20-story building. Development of the Saturn is underway at Huntsville, Alabama, under the direction of the National Aeronautics and Space Administration. Dr. Werner von Braun and his experienced development team started the project in September 1958. To save time, the experts decided to cluster 8 rocket engines of a proven type. Basic engineering problems have been solved in the development of military rockets by the Army Ordnance Missile Command. Work began on the booster, an assembly of 9 tanks to carry fuel and oxygen to provide 1.5 million pounds of thrust. The 22-foot diameter Saturn will tower far above its predecessors, the Redstone and Jupiter ballistic missiles. Fabricating all parts of the rocket from the largest to the smallest, personnel of the 10 laboratories are working with a sense of great accomplishment. Scientists and technicians brought here from all sections of the country were sure they could produce the challenging objective, a space transportation system. First, they built rings that would embrace the tanks. The gigantic size of the first stage could now be envisioned. Assembly and checking began within the enormous hangar-type buildings. Hundreds of tests were conducted in other laboratories. One major problem to be solved was to prevent sloshing of the fuel during flight. Model tanks helped to find the answer. Wind tunnel tests of models verified the flight stability of the shape of the booster. An improved and simplified version of the rocket motor used for U.S. ballistic missiles was to be grouped in a cluster of 8 engines. These motors have already been tested singly and have withstood the rigorous firings. Facilities had to be altered to handle and test this new giant. Major alterations changed a Jupiter missile test tower so it could accommodate the Saturn. Models were used for planning purposes. Modifications have been completed on the 178-foot test tower. Complex instrumentation has been installed. The tower must withstand the powerful blast of 8 rocket motors, generating more thrust than has ever been released. This will be the largest booster yet tested by the free world. Awaiting the first firing, the motor cluster section has been fitted to the test tower. Small-scale motors generating a thrust of 500 pounds each have performed as expected in testing the concept. The scientists are now confident that the full-sized Saturn can accomplish the planned space missions. Studies have long been underway to select space tasks of more immediate value. One may be a communications system capable of instantaneous transmission of television, telephone, or telegraph signals to any point on Earth. An ideal communication system would include 3 suitably equipped satellites orbiting around the Earth. At 22,300 miles altitude, the satellites would remain over the same spot on Earth. Messages would be relayed to one satellite, to another, and then back to Earth. The Saturn can place these instrumentation packages in the correct position over the equator. At an altitude where the atmosphere thins out, the burned out first stage will separate and start falling back toward the ocean below. Parachutes will open to lower the booster into the sea. Waiting ships will follow radio signals to the landing spot to recover the spent booster for later study. Soon after the first stage is dropped, the second stage motors ignite, increasing the speed tremendously. The third stage builds up the velocity and pushes the payload to the proper altitude and speed. A protective cone is ejected, the sides opened, and the satellite pushed forward to open to its full size. How the satellite emerges can be seen from this 1:12 scale model. The nose cone containing the payload is many times larger than an average-sized man. As the last stage nears the planned location over the Earth, the nose cone is pushed ahead of the payload. A small sidekick rocket moves the cone out of the path. The container walls are opened by spring action, and the satellite is ejected. The container is discarded. By automatic action, the communications equipment is opened to its full size, extending 27 feet from one side to the other. 2 antennas face the Earth, and 2 may be directed toward the other communications satellites. Power is generated by the solar deck, the oblong white objects. These always follow the sun, from which they draw energy. There are many potential uses for the Saturn. One of the first experiments may be to learn more about the moon. Let us follow an artist's conception of the sequence by which instruments could be soft landed on the moon. Another Saturn could send 2 or 3 men around the moon and return them safely to Earth. To place instruments on the moon in a soft landing will be one of the more important steps of the National Space Program. The same firing sequence will lift the third stage containing the instruments to the vicinity of the moon. After the necessary speed of more than 24,000 miles per hour is reached, the cover of the payload is ejected. The wheels of a roving moon vehicle will then inflate. Small pressure chambers within the third stage will turn the rocket so that the motors will face the moon. A burst from the rockets will slow the instruments for a soft landing. The scientific package can include a traveling TV broadcasting station or a stationary information gathering package. Another immediate use of Saturn may be a manned trip around the moon. 2 passengers can ride within the rocket nose cone, enabling them to observe the dark side of the moon and to gather scientific information about the natural satellite. As the passenger carrying nose cone starts back toward Earth, it must be slowed down so that it will not burn by friction in the Earth's atmosphere. Parachutes will slow the cone in the same way that the Army recovered several missile nose cones. Flashing lights, radio signals, water-dissolved dye, and a buoy will direct waiting ships to the floating spaceship. When the rocket is completed in Alabama, it must be moved to Cape Canaveral, Florida. It will be transported on a trailer from the assembly building to a loading dock. A river barge will probably carry the giant rocket to Florida. It will begin the 17-day journey on the Tennessee River. tug will pull the unusual cargo on its long trip. First down the Tennessee to the Ohio River, then down the Mississippi, across the Gulf of Mexico, around the Florida Peninsula, to Cape Canaveral. At the specially constructed launching site, the booster and upper stages will be erected. A 305-foot superstructure will be used for pre-launch work and for checking the fueling. Before firing time, the tower will be moved by rail to a safe distance from the powerful space rocket. When fully fueled, the rocket will weigh close to 580 tons, of which 500 tons are fuel and oxidizer. The blockhouse containing checking, firing, and tracking instrumentation has been planned to provide the necessary equipment and to assure the safety of those who must remain during the fueling and firing operations. Before the firing, all buildings and equipment must be ready, inspected, and in working order. Construction is now well within the planned time schedules. The erection of Saturn at the firing site will mean the end of development work on the first test vehicle. As the rocket starts its journey to the moon or the planets, man will truly have entered the age of space. This space workhorse can be the means of improving our life on Earth by more accurate weather predictions and worldwide communications. But beyond this, who knows what fantastic changes will come? Each bit of knowledge will bring man closer to the stars.